Let's look at a couple more examples of graphing rational functions by using intercepts and asymptotes. So I could start this by looking at it in my graphing calculator. So just to be careful there, I'm going to enter it as x squared minus x minus 2 with parentheses around the numerator and also around the denominator. So make sure you enter it like this. And when I do, okay, I see the graph definitely has two vertical asymptotes, but it's really hard to see what the X and Y intercepts are. If we use the ideas from the previous lesson, I'm going to start by noting that the Y-intercept is going to be the ratio of the last two numbers. Again, that came from if you put 0 into all the x's, you would be left with -2 over -20. So that is x equals 0, and then you have -2 over -20 for the y value. And of course, this simplifies to 0, 1 over 10. So that's the y-intercept. If you want the horizontal asymptote, that is going to be the ratio of the numbers in front of the highest powered x terms. So it's 1 over 1. So the horizontal asymptote is y is equal to 1. What I don't know is what are the x-intercepts and the vertical asymptote. These two things came from where the numerators and denominators were equal to 0. It's hard to see what those are based off the way this graph is written, so what I'm going to do is take my equation and factor it. Alright, the numerator factors as, let's see, that's got to be x minus 2 times x plus 1. And the denominator is, okay, that's got to be x plus 5 and x minus 4. Okay, now that it's factored, I can see that the numerator is 0 if I put in 2 and -1. These points are x-intercepts. That was 2, 0, and also -1, 0. And the vertical asymptotes are going to come from where the denominator is 0, which is x is equal to -5, and also x is equal to +4. I'm going to take all this information, put it on this graph, and sketch my equation around it. All right, so I'm going to start, I guess, with the vertical asymptotes. There is one at -5. There is another one at +4. All right, the horizontal asymptote is y is equal to 1. The x-intercepts are at -1, 0, and also 2, 0. And the y-intercept is 0, 1/10. That's, pretty small, but that's like right there. Okay, so according to my graphing calculator, my rational function approaches the asymptotes and goes through these intercepts. That's what's happening in the middle of the graph. And then over here, the graph approaches the asymptotes this way. So I'm going to sketch that in. So my graph looks like this. Something like this. And that's a pretty decent picture. There is one other thing to consider. Is it possible that the graph could cross over the horizontal asymptote? So the horizontal asymptote is y is equal to 1. And the way I'm going to figure that out is by taking this function, setting it equal to 1, and solving for x. Does this ever happen? And it looks like a very difficult equation. However, I'm going to cross multiply this thing to the other side and change my equation to x squared minus x minus 2 is equal to x squared plus x minus 20. I'm trying to solve this for x so I can subtract x squared from both sides. It leaves me with -x minus 2 is equal to x minus 20. I then guess I will add x to both sides, and also at the same time add 20 to both sides. And this gives me 18 is equal to 2x after dividing both sides by 2. I get that x is equal to 9. What all this work means is the function takes on a value of 1 at x is equal to 9. Here's x is equal to 9. The graph actually equals the horizontal asymptote here, so I'm going to mark that on my graph. This means the graph goes to this point, equals 1, crosses over, and starts approaching the asymptote from the other side. I'd say this is a complete picture of this rational function where I found my y-intercepts, horizontal asymptote. Those came from the ratios of the numbers at the beginning and the end of the function. The x-intercept came from where the numerator was 0. The vertical asymptotes came from where the denominator was 0. I sketched all those things and put the graph in around it, but then I added this one extra requirement of, well, it's possible that this graph could cross over the horizontal asymptote. I set my equation equal to that value, solved it for x, and found that this was the only time at which it happens. So here's a complete picture of the graph x squared minus x minus 2 divided by x squared plus x minus 20. So let's try this again, but in a slightly different example. Here we have x plus 1 divided by x squared minus 16. Here I'm noticing that, well, there's not an x squared in the numerator, although there is one in the denominator. If you'd like, in place of y1, you can enter x plus 1 divided by x squared minus 16. And I just did that, and the graph, it's not very good. I mean, I can tell that there might be a couple of vertical asymptotes, but the rest is like very close to the x-axis, and I can't really see it too well. All right, so I guess one place to go would be, well, what's the y-intercept? What's the horizontal asymptote? This one's tricky in terms of the horizontal asymptote because now if I look at the numerator and the denominator, they don't both have x squareds in it. If this is the case, the numerator is technically 0x squared plus x plus 1 divided by x squared minus 16. So the horizontal asymptote, the ratio is actually 0 over 1 because I have to compare both x squareds. There's a 0 up here and a 1 down here, whereas you can't just say 1 over 1 this time because you're comparing different powered exponents. This means the horizontal asymptote is simply 0. Now the y-intercept is going to be the ratio of the numbers at the end. Well, this works. I have a 1 and a negative 16. This means the y-intercept is 0, negative 1/16. To determine the x-intercepts and vertical asymptotes, I now have to factor the numerator and the denominator. Well, the numerator can't be factored. You'd have to leave it as x plus 1, but the denominator can factor as x minus 4 times x plus 4. This way, I can see there's actually one x-intercept, negative 1, 0, whereas there are two vertical asymptotes. Those would be x is equal to 4 and negative 4. So I'm going to plot all of these on the xy axis that we have here. So starting with the vertical asymptote, there are two of them. One is at negative 4, the other is at positive 4. The horizontal asymptote is y is equal to 0. The only x-intercept is at negative 1, 0. And the y-intercept is 0, negative 1/16, so I'll put it right there. So according to my graphing calculator, I see that it drops down and goes through these two intercepts in the middle of the graph. So I see something that looks like this. And on the ends of the graph, I see that we have the graph is above up here, yet it is below down here like this. I can fill in the spaces better than what I see on my graphing calculator because I know the graph has to go through those intercepts and then approach all the asymptotes. Okay, last question for this is, does the graph cross the horizontal asymptote? And if we were to solve this like last time, what you'd have to do is take your equation and set it equal to the horizontal asymptote, which is 0. This time, if you multiply the denominator over to the side, you're simply left with x plus 1 is 0. And the answer here, when you solve for x is equal to -1. But we actually already knew that if you look at the graph. Here's the horizontal asymptote. I can actually see that it crosses over at this spot here, which was this x-intercept. So it was actually redundant in this problem to answer this question because we actually solved this already once we figured out this value here. But really this equation does work, and that is it for this problem.